On the moon, danger does not always hide in darkness. Sometimes it shines. Look at a full moon, and one of the brightest marks you will see is a white scar in the southern highlands. From Earth, it looks almost beautiful, a glowing crater with rays stretching outward like cracks across glass. That scar is Tycho Crater. But if you were standing there in a spacesuit, beauty would disappear fast. Around you would be cliffs taller than Earth's tallest skyscrapers. The ground beneath your boots would be broken, sharp, and unstable. City block-sized boulders would sit on slopes that already look ready to slide. And above you, there would be no atmosphere, no wind, no sound, only silence. Tycho is about 85 kilometers wide, almost 5 kilometers deep, and surrounded by debris launched across the moon by one of the most violent impacts in recent lunar history. This is not just a crater, it is a frozen explosion. And today, we are entering the most dangerous place on the moon. Welcome to Cosmic Silence. Tycho Crater sits in the moon's southern highlands at roughly 43 degrees south latitude. It is not the biggest crater on the moon. In fact, the moon has impact basins hundreds and even thousands of kilometers wider. So why does Tycho stand out? Because Tycho is young. Most large lunar craters are extremely ancient, billions of years old. Time has softened them. Tiny meteorite impacts have worn them down. Space radiation has darkened their surfaces. Their edges have faded into the background. Tycho is different. Scientists estimate that Tycho formed around 108 to 109 million years ago. That sounds ancient to us, but for the moon, it is almost recent. When Tycho formed, dinosaurs were still walking on Earth. Then, somewhere in space, an asteroid or comet several kilometers wide crossed the moon's path. It struck at tremendous speed, possibly around 18 kilometers per second. In one instant, solid rock behaved like liquid. The lunar crust was crushed, melted, blasted upward, and thrown outward in every direction. And because the moon has no thick atmosphere, nothing slowed the debris down. Imagine standing thousands of kilometers away from Tycho during that moment. No thunder, no roar, just black sky. Then fragments of the moon itself begin raining down from space. That is what makes Tycho so terrifying. Its violence did not stay inside the crater, it spread across the moon. One ray appears to reach the Apollo 17 landing region more than 2,000 kilometers away. That means the impact fired material across distances larger than entire countries on Earth. And here is the question. If one crater can throw debris that far, what would it be like to land near the source? Before we go inside Tycho, pause for a second and think about this. If NASA or another space agency announced a mission to this crater, would you want astronauts to go there, or would you call it too dangerous? Drop your answer in the comments, because by the end, your opinion might change. From orbit, Tycho looks almost perfectly organized. It has a raised rim, terraced walls, a crater floor, and a mountain-like peak in the center. But that clean shape is deceptive. Up close, Tycho is chaos. The crater drops around 4.7 kilometers from rim to floor. That is deeper than many major mountain valleys on Earth. Its central peak rises about 2 to 2.4 kilometers above the crater floor. In simple terms, Tycho is not a hole, it is a mountain range inside a blast crater. That central peak formed because the impact was so powerful that the ground rebounded after being crushed downward. Think of dropping a stone into water, the surface splashes down, then rebounds upward. Something similar happened here, except the water was solid lunar crust, briefly moving under extreme impact force. The result is a mountain made of deep lunar material, pushed upward in seconds. And that mountain is covered with danger. NASA's Lunar Reconnaissance Orbiter has captured images of huge rock fragments on Tycho's central peak. Some are around 10 meters wide, others are much larger. One boulder near the summit is about 120 meters across. Another block on the crater floor has been measured at roughly 320 meters wide. That is not a rock. That is a building-sized obstacle lying in a place where a rover cannot simply drive around casually. Now imagine an astronaut standing near it. The horizon is close because the moon is smaller than Earth. The sun is low. Shadows are completely black. A boulder the size of a stadium casts a wall of darkness across the ground. Your helmet lights catch sharp fragments, loose dust, and slopes that disappear into shadow. Every step matters. Every wheel turn matters. And that brings us to the second danger, the slopes. Many of Tycho's central peak slopes fall between roughly 28 and 35 degrees. That may sound like a small number, but for loose, dry material, that is near the point where gravity starts winning. On Earth, sand, gravel, or dust piled too steeply eventually slides. On the Moon, there is no rain and no vegetation, but there is still gravity. Loose material can still move. The difference is that on the Moon, you may not hear it coming. No atmosphere means no sound traveling through the air. A rockfall could begin above you, and the first warning might be the shadow moving across the ground. Tycho's walls also show giant terraces, huge step-like layers formed when sections of the crater wall collapsed inward after the impact. These terraces are not decorative, they are scars from failure. They show that the crater tried to stabilize itself after being violently excavated. But stable on the Moon does not mean safe forever. Small meteorite impacts still shake the surface. Thermal stress still cracks rocks. Moonquakes still happen. Apollo seismometers proved that the Moon is not completely dead. Some moonquakes are deep, some are caused by temperature changes, some are caused by impacts. The most concerning shallow moonquakes can occur tens of kilometers beneath the surface and may reach around magnitude 5.5. On Earth, that would be serious. On the Moon, it can be stranger. Because the Moon is dry and rigid, seismic energy can ring through it for a long time. The shaking does not fade the same way it does on Earth. Now place that shaking inside Tycho, a crater with steep walls, loose debris, fractured melt, and boulders already resting on slopes. This is where the danger becomes personal. Imagine a future lunar crew parks a rover near the base of Tycho's central peak. They are not reckless. They have maps, suits, backup oxygen, and robotic scouts. But as they collect samples, a small impact happens miles away. The ground trembles. A slope above them shifts. A boulder that has been balanced for millions of years finally moves. There is no warning rumble, only motion. That is Tycho's threat. Not monsters, not mystery. Physics, and yet the same violence that makes Tycho dangerous also makes it scientifically priceless. The crater floor is covered in impact melt. That means rock became hot enough to melt during the collision, then flowed and froze again. To a viewer, it may look like old volcanic lava, but it is not lava from inside the Moon. It is impact melt rock liquefied by the force of collision. That distinction is important. A volcano brings melted rock from below. Tycho made melted rock by smashing the surface so hard that stone briefly turned into liquid. That frozen melt preserves the violence of the impact like a crime scene. Some areas look smooth from above, but high-resolution images reveal cracks, flow-like shapes, melt ponds, and rough broken surfaces. A lander might see flat ground from far away, but close up, that surface could be filled with ridges, sharp textures, and hidden hazards. This is why Tycho would be a nightmare landing zone. A spacecraft would need extremely precise navigation. It would have to avoid boulder fields, steep slopes, broken melt sheets, and dangerous shadows. A rover would need to move slowly, with careful route planning. Astronauts would have to manage lighting conditions, terrain traps, and the constant risk of becoming too far from safety. And there is another hazard people often forget: temperature. The Moon has no air to spread heat around. In sunlight, surfaces can become brutally hot. In darkness, they can become extremely cold. At Tycho, the steep walls and giant boulders create extreme lighting contrasts. One side of a rock may bake in sunlight, while the other side sits in deep freeze. For machines, that means stress. For astronauts, it means danger. Equipment can expand and contract, batteries can struggle, wheels and joints can face sharp temperature shifts. A path that looks safe in one lighting condition may become invisible in another. On Earth, shadows are just darker areas. On the Moon, shadows can be traps. But Tycho's greatest scientific mystery may not even be inside the crater. It may be more than 2,000 kilometers away, at the Apollo 17 landing site. Apollo 17 astronauts did not land at Tycho. They landed in Taurus-Littrow Valley. But some of the material there may have been connected to Tycho's impact. Researchers have studied whether debris from Tycho helped trigger landslides or deposited material near the Apollo 17 region. Some impact melt glasses from Apollo 17 have ages close to 108 million years, close to Tycho's estimated age. This is still debated, and that uncertainty makes the story better, not weaker, because it means Tycho is not fully solved. If Apollo 17 samples truly include Tycho material, then the crater's blast reached across the moon and left evidence at the last place humans walked. If not, then scientists still need direct samples from Tycho itself to lock down its exact history. Either way, Tycho remains one of the most important lunar targets. It is young enough to preserve fresh impact features, it is large enough to expose deep crust, it is bright enough to be seen from Earth, and it is dangerous enough to test everything we think we know about landing and surviving on the moon. So here is another question. If humanity returns to the moon for science, should we go after the safest places first or the most valuable ones, even if they are dangerous? Because Tycho is exactly that dilemma. Safe missions prefer smooth plains. Science wants places like Tycho. Its central peak may contain rocks lifted from deep inside the lunar crust. Its floor preserves impact melt. Its rays record how debris travels across an airless world. Its ejector blanket shows how one impact can reshape landscapes far beyond the crater rim. But every scientific reward comes with operational risk. You cannot study the central peak without approaching steep terrain. You cannot sample fresh melt without crossing rough surfaces. You cannot explore the crater floor without dealing with shadows, boulders, and broken ground. Tycho does not give answers easily. It makes you pay for them. That is why calling it the most dangerous place on the moon is not just drama. It is a way of understanding what danger really means in space exploration. Danger is not always the deepest darkness. It is not always the coldest crater. Sometimes, danger is a place that looks inviting from far away, bright, beautiful, perfectly visible, but becomes hostile the closer you get. Tycho is that place. From Earth, it is a white mark on the moon. From orbit, it is a spectacular crater. From the surface, it would be a world of broken stone, towering cliffs, unstable slopes, black shadows, frozen melt, and silent motion. It is the moon's violence preserved in high definition. A place where a mountain-sized object struck the surface, excavated billions of tons of rock, melted the crust, launched debris across the lunar face, and left behind a crater that still looks fresh after more than 100 million years. And perhaps that is the most haunting part. Tycho is not dangerous because it is active like a volcano. It is dangerous because the disaster already happened and the wreckage is still there. So the next time you look at the full moon and see that bright, white crater in the southern highlands, remember what you are really seeing. Not just a beautiful lunar landmark. Not just a crater, a preserved blast zone. A place where the moon was shattered, melted, and left silent. And if you could choose the next great lunar destination, would you send astronauts into Tycho, or would you leave this frozen catastrophe untouched? Share your answer in the comments, because future moon missions may face exactly that choice. And if you want to explore more hidden dangers across the moon, from shadowed polar craters to ancient lava pits, subscribe to Cosmic Silence. Because on the moon, silence does not mean safety. At Tycho Crater, silence is simply what remains after the violence.